Complete the table below. The first one has been done for you. For each statement, you must state if it is always true, sometimes true, or never true, and we need to give a reason in each case. So the example we've been given is that the quadratic equation ax squared plus bx plus c is equal to 0 has two real roots. And we know that that is sometimes true, because if the discriminant was equal to 0 or less than 0, then there wouldn't be two real roots. So that statement is sometimes true. So we now need to do, when a real value of x is substituted in to x squared minus 6x plus 10, the result is positive. Now the best way to check this is by completing the square on this, because that's going to tell me what the minimum value could be. So the perfect square that goes along with x squared minus 6x is x minus 3. So I've just halved the 6 there. Now this would give me a plus 9. So I need to add one more to that to get to the 10. So I've completed the square. And now I can see that when I substitute any value of x into this bit is always going to be positive. Therefore, the minimum this can possibly be is 1. So I'm going to say minimum is 1 when x is 3. And if the minimum it can be is 1, that means it's always bigger than 1, therefore it's always positive. So that is always true. Next, if ax is greater than b, then x is greater than b over a. So this is an inequalities question, and we can see that to move from there to there, they've divided both sides by a. Notice that the direction of the inequality has stayed the same, which would be fine if a was positive, but if a was negative, they would have had to have flipped the sign. So this statement is sometimes true, and I'm going to say that ax equals b, then x is greater than b over a if a is positive. But if x was negative, if a was negative, that would mean that x would be less than b over a. The sign would flip if a was negative. So that's why it's sometimes true. And part 3, the difference between consecutive square numbers is odd. So consecutive square numbers. So my consecutive square numbers are n squared and n plus 1 squared. And we're talking about the difference between them. So I want to take those away. I want to do the big one, take away the small one. So I'm going to do the n plus 1 all squared, take away the n squared. Expanding these brackets, n squared, n times 1, so n, but 2 of them, so 2n, one squared. And not forgetting the minus n squared there. Collecting up the like terms, n squared minus n squared, they cancel out, so I get left with 2n plus 1. Now I know that 2n is always even, so 2n plus 1 is always odd. So this statement is always true. The difference between consecutive square numbers is always odd.